Hello dear students. In the previous episode, we have studied how to write the subshell-wise electronic configuration of elements. And we have also studied the speciality of chromium and copper. So in the case of chromium and copper, we follow a special property, half-filled or fully filled subshells are more stable. Half-filled or fully filled subshells are more stable. Now we are going to study the different blocks in the periodic table. They are S block, P block, D block and F block.
Today we are going to discuss different blocks in the periodic table. They are S block, P block, D block and F block. So look at the periodic table. The first group and second group, they are S block elements. And group number 3 to 12, they are D block elements. Then group number 13 to 18, they are P block elements. And the last row, lanthanoids and actinoids, they belong to F block. So 4 block, first and second group S block, then 3 to 12 D block, 13 to 18 P block, and the last 2 rows, lanthanides and actinides, they are the continuation of 6th and 7th period. They belong to F block. So this in the case of S block, the elements are first group and second group elements. And first group include hydrogen, lithium, sodium, etc. Second group include barium, magnesium, etc. Then P block 13 to 18 and D block 3 to 12 and F block lanthanoids and actinoids. Let us discuss how to find the block, period and group. So first let us study S block. See the electronic configuration. Sodium 11, 1s2, 2s2, 2p6, 3s1. So block means how to find out the block. The block is the last subshell, that's in which the last electrons are entered. So in the case of sodium, the last electrons are entered in 3s subshell. So the block is S. Then next coming this period. How to find out the period? Last year you have studied that period is the number of shells. Period is the number of shells. And so here the number of shell 1, that means it is K shell, 2 it is L shell and 3 it is M shell. So here there are 3 shells. So the period number is same as the shell number of the outermost shell, or it is the total number of shell, or it is the same as the shell number of the outermost shell. So here the outermost subshell is 3. Its shell number is 3. So the period is 3. Then group. For S block element, the number of electron in the outermost S subshell will be the group number. So the group is the number of electrons in the outermost S subshell. 3s is the outermost S subshell. So here 1 electron, so group is 1. So one more example. Then potassium 19. You know how to write the electronic configuration, no? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So the block is the last electron is entered in 4s subshell. So the last subshell is S. So block S. Then period. Here number of shell or the last shell, that is 4. Then group. Last electron in S subshell, that is 1. So group is 1. Then let us see the properties of S block elements. So you know that the S block elements are first group and the second group. So the first group and second group, they are all metals. So S block elements are all metal. And as they contain 1 or 2 electron in the outermost shell, during chemical reaction they lose 1 or 2 electron. So the oxidation state of S block element is +1 or +2. First group +1 and second group +2. And they are usually high electropositive in nature because they lose electrons, and their electronegativity is less because they have tendency to lose electron, not gain electron. Electronegativity means tendency to gain electron. And they have less ionization energy because they contain only 1 or 2 electron in the outermost shell. So less energy is required to remove the electron. So they have less ionization energy. The properties of S block elements are, they are all metals. They show +1 or +2 oxidation state. They form positive ion. They have a low ionization energy, low electronegativity, and high electropositivity. Then let us come to the second block, that is P block. P block means 13 to 18th group. So example Cl, chlorine, atomic number 17. So the electronic, you know how to write the electronic configuration, no? 2p6, 3s2, 3p5. So the last electron is entered in 3p subshell. So the block is P. And the last shell, that is the period, last shell is 3. Then group, there is a difference between S block and P block. Here the group is 12 plus last electrons in the last P shell. So learn this formula by heart. So group number, how to find out the group number of P block? 12 plus electrons in the last P subshell. 12 plus electrons in the last P subshell is 5. So the group number is 17. So block and period same as S block. The method is same, but group number, how to find out the group number? It is 12 plus electrons in the last P subshell. 12 plus 5, that is equal to 7. P block starts in the periodic table after 12 groups. P block starts in the periodic table after 12 group. That means first and second group is S block, and 3 to 12 is D block. So after leaving 12 groups, P block come. So we are adding 12. 12 plus electrons in the last P subshell. One more example. Then oxygen 8. 1s2, 2s2, 2p4. So block, the last subshell in which the last electrons are added, that is P. Then period, last shell, not subshell, last shell, that is 2. Then group 12 plus last electron in the P subshell, 12 plus 4, 16. So I think You understood this? Then characteristics of p block elements. So you know that p block elements belong to 13 to 18 the group. So they include solid, liquid and gas, like aluminium, 13th group, it is solid. Then this bromine, it belongs to 17th group, it exists in liquid state. Oxygen, it belongs to 16th group, it exists in gas. So p block elements exist in solid, liquid and gas. And they include metals, non-metals and metalloids, like aluminium, it is a metal. Oxygen, chlorine, fluorine, they exist in, they are non-metals. Then silicon, it is a non-metalloids. Metalloid means which shows the properties of metal as well as non-metal. So these p block elements include metal, non-metals and metalloid. And they show a periodicity in their properties. That means 13th group, they have this less ionization energy compared to 18th group. But from moving from left to right across a periodic table, ionization energy increases 13 to 18 and electropositivity decreases and electronegativity increases 13 to 18. So they show a periodicity in their properties. So the characteristics of p block element, they exist in solid, liquid and gas. They include metals, non-metals and metalloids. And they show a periodicity in their properties. So their oxidation state, 13th group, they show positive 3 oxidation state. And the 17th group, they show negative 1 oxidation state. And 18th group, you know, they are inert gases. They are inert in their chemical reaction because their outermost shell is complete. So next is D block element. Scandium 21. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So the last electrons enter in 4s subshell, not 3d. You won't make a mistake. So the last electron enter in 3d, not 4s. The last electron enter in 3d, not 4s. And but so the block is D, not S. The block is D. So you may ask one question, why it is written like that? Why the last electron enter into 3D instead of 4s? Because the energy of 3D is greater than 4s. So 3D is the penultimate shell. 4s is the outermost shell and 3D is the penultimate shell. Last electron gone to 3D. So the block is D, not S. And the period, it is the last shell, the outermost shell, that is not 3, it is 4. So then how to find the group? Group is S, last S electron last S electron plus D electrons, that is 2 plus 1, 3, S plus D. So outermost S plus D, learn by heart, outermost S plus D, electrons in outermost S subshell and D subshell. So one more example, chromium 24. You know the speciality of chromium now, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, because half filled or completely filled subshells are more stable. So block. the last electron go to D block, so D. Then period, outermost shell, not subshell, 4. Then group, electrons in the outermost S subshell and D subshell, 1 plus 5, 6. So group, for finding group, 3 blocks. S block, outer electrons in the last S subshell. Then P block, how to find the group? The electrons in the last P subshell plus 12. Outer electrons in the outermost P subshell plus 12. For D block, the electrons in the outermost S subshell and D subshell. S plus D, electrons in the outermost S subshell and D subshell. Then characteristics of D block elements. D block elements, they show variable oxidation state like FeCl2, FeCl3. In FeCl2, the oxidation state of Fe is positive 2. In FeCl3, oxidation state of Fe is positive 3. Another CuCl2. So here the oxidation state of copper is positive 2. Then say FeCl2. The atomic number of Fe is 26. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Then they may ask a question, what is the electronic configuration of Fe ion in FeCl2? So the oxidation state is Fe2 plus. So when this transition element take part in chemical reaction, they lose electrons in the outermost 4s subshell as well as from the outermost 3d subshell. Outermost, not outermost, penultimate 3d subshell. So in the case of D block element, when they take part in chemical reaction, they lose electrons in the outermost shell as well as penultimate shell. That means from the 4s subshell and from the 3d subshell. So first they lose electron from 4s subshell, not 3d, because 4s is the outermost. So they lose 2 electrons. So the electronic configuration of Fe2 plus is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. In FeCl3, oxidation state is 3 plus. So they lose electron, 2 electron from 4s and 1 from the penultimate shell. That is 1s2, 2s2, 2p6, 3s2, 3p6 and 3d5. So look the example, it is very important. So the transition elements show variable oxidation state because during chemical reaction they lose electron from the outermost shell and the penultimate shell because the energy difference between the outermost S subshell and D subshell is very small. So they lose electron from the outermost shell and the penultimate shell. So in the case of Fe2 plus, the Fe lose electron from 4s subshell and Fe3 plus 2 electron from 4s and 1 electron from 3d. So that is why the transition element, D block elements are also called a transition element. They show variable oxidation state and they form colored compounds. They all are metals. They show horizontal similarity. That means in the case of S block and P block, they show similarity, the elements show similarity only in groups. But in transition element or D block element, they show similarity in group as well as period. That is why it is said that the transition element or D block element show horizontal similarity. So 4 properties. First one, transition D block element, they all are metal. Second property, they show variable oxidation state. Third property, they form colored compound. Fourth property, they show horizontal similarity. Then another important question, why the D block elements show this variable oxidation state? That is very important. So the reason is that in the case of D block element, the difference in energy between the outermost S subshell and penultimate D subshell is very small. Hence, under suitable condition, electrons in the D subshell also take part in chemical reaction. That means they lose electron from the D subshell also. Hence, transition elements show variable oxidation states. So next is F block. So you don't have to study the details of F block, you just learn the properties. So not D block, F block element. Next is F block element. So S block, P block and D block you have to study detail, but F block element you just learn the properties. So F block element means here the last electron goes to last F subshell. That is why they are called the F block element. Lanthanoids and actinoids are a F block element. Like D block element, most of them show variable oxidation state, variable valency. Most of the actinoids are radioactive and are called artificial elements. They are usually artificial elements. Radioactive means they can emit alpha, beta, gamma rays. Uranium, thorium, plutonium are used as fuel in nuclear reactors. Nuclear reactors used to generate electricity from nuclear power station. Most of them are used as catalyst. Most of them are used as catalyst in the petroleum industry. Catalyst means which changes the rate of chemical reaction. So F block element, they are they usually show variable oxidation state, and actinoids are radioactive, and uranium, thorium, etc. are used as fuel in nuclear reactors. Many of them are used as catalyst in the petroleum industry. So the properties of S blocker, P blocker, D blocker, F blocker, that you have to learn by heart, and how to find period, group and block. So S block means first and second group, P block 13 to 18th group, D block 3 to 12, F block lanthanoids and.
Now we have discussed how to find the group, period and block of different elements. So we have studied the S block elements, P block elements, D block elements, F block elements and their properties. And we also studied how to find the group, period and block. So this F block elements, they have various uses in our daily life. They are used in atomic reactors and they are radioactive elements. And we also studied the special property of D block element. They are also called transition elements. And in their transition elements show variable oxidation state.